The US is quietly turning retired coal plants into 100-hour iron-air batteries so its grid doesn't crash under AI's exploding power hunger.
So, we're literally using the ghosts of the fossil age to power the AI age?
Exactly. Old coal stacks and steel mills are being rewired into multi-day battery yards and factories because AI data centers are about to hit the grid like a tidal wave. Right now, US data centers use roughly 4.5% of the country's electricity, but new forecasts say that could double to between 9% and even 17% by 2030. In some states like Virginia, data centers alone could burn more than half of the grid's power by the end of the decade.
And AI makes that worse, right? How hungry is it compared to normal internet stuff?
A typical web search uses about 0.3 watt-hours, but an AI chat like a ChatGPT query can draw around 2.9 watt-hours, roughly 10 times more. The Electric Power Research Institute thinks AI's dedicated load could jump from around 5 gigawatts today to more than 50 gigawatts by 2030.
So if we don't build something big, we're looking at data centers fighting hospitals and homes for electricity, blackouts, or prices spiking.
That's the fear. Rolling constraints, emergency gas plants, and dirtier backup generation, unless we find cheap, massive ways to stretch clean power across multi-day gaps. That's where one very weird battery comes in, but before we dive in, like and subscribe our channel for more of these videos.
Right. So what's this weird battery you on about now?
Form Energy's iron-air system built to run for 100 hours straight.
Iron air? What do you mean?
The core trick is reversible rusting. When the battery discharges, it breathes in oxygen and turns tiny iron pellets into rust. When you charge it, you push electricity back in, the rust turns back into iron, and the battery breathes out oxygen again. Each cell uses cheap iron, water-based electrolyte, and air electrodes. No lithium, no rare earths, stacked into modules the size of shipping containers, then grouped into megawatt-scale blocks.
So it's not a super fast phone battery, it's more like a giant slow lung for the grid.
Exactly. Lithium packs are great for 2 to 4 hour bursts, but they're still too expensive to cover a whole long, cloudy, windless spell. Iron air is built to fill that 3 to 4 day hole. The boldest part is where they're putting these batteries. Xcel Energy is installing two 10 megawatt, 1,000 megawatt hour iron air systems right at retiring coal plants in Minnesota and Colorado. Each unit can push out 10 megawatts for 100 hours, sitting on the brownfield footprints of Sherburne County Generating Station and Comanche Generating Station, sites that used to burn coal and deliver gigawatts.
So instead of demolishing a coal plant and walking away, you keep the grid connections and turn it into a battery farm?
Exactly. You reuse the transmission lines, the land, even some of the workforce, and stack iron air containers where coal boilers used to stand. These are still pilots. 10 megawatts is tiny compared to the 2.2 gigawatt coal station Sherco used to be, but they're big enough to show whether multi-day storage can actually stand in when renewables sag.
And what about that factory you mentioned? How does a dead mill become part of this story?
Form's first high-volume plant, Form Factory 1, is built on the site of the old Weirton Steel Mill in West Virginia, a Rust Belt icon that once employed over 12,000 steel workers. They've turned 55 acres of industrial ruins into a 550,000 square foot battery factory, aiming for 500 megawatts of annual production and hundreds of new jobs by 2028.
So we're literally taking steel towns and coal towns and retraining people to build AI-era batteries instead of pipes and rebar?
That's the idea, and Washington is backing it with around $150 million of federal support to add new lines and bring production up to 20 gigawatt hours per year by 2027. The craziest project announced so far links this directly to AI, a 300 megawatt, 30 gigawatt hour iron-air battery system with Xcel Energy to help power a new Google data center in Minnesota.
30 gigawatt hours. How big is that in normal people terms?
30 gigawatts, GW, is an immense amount of continuous power. In practical terms, 30 gigawatts can simultaneously charge over 441 million standard electric vehicles, assuming a 68 kilowatt-hour battery taking 15 minutes to charge, or supply the daily electricity needs of roughly 22 million households, more than all homes in California. It's the largest battery by stored energy ever announced globally, and it's specifically designed to keep a big AI-heavy data center running for days when the grid is stressed. Every container in that system will be built at the Weirton factory, then shipped out to sit behind a data center whose AI queries are roughly 10 times more power-hungry than a standard search.
So when Google says, we want 24/7 clean power, this is one of the secret tools that makes that promise believable. At least on paper?
Yes, but it's also a test of whether multi-day batteries become a standard part of the data center toolkit, or stay a niche experiment.
Okay, real talk. If AI demand can jump to 50 gigawatts and data center consumption could be hundreds of terawatt hours by 2030, can a handful of coal-to-battery projects and one giant Google battery really save the US grid?
No single technology can. Forecasts for US AI and data center power use range from roughly 200 to nearly 1,000 terawatt hours a year, depending on how fast models scale and how efficient chips and cooling get. Iron-air batteries shine in a very specific role, bridging multi-day gaps for wind and solar using cheap, abundant materials and reusing old coal infrastructure. But those projects ride alongside massive new solar and wind builds, grid upgrades, efficiency gains, and, in the near term, a lot of extra natural gas generation that grid planners still expect to dominate new capacity for AI.
So the real question isn't, are these batteries magic? It's, do we scale them fast enough in the right places before AI demand outruns everything else?
Exactly. If AI data center build-out outruns storage, transmission, and clean generation, we get higher prices, more fossil backup, and a grid that feels fragile right when we're wiring critical services into it. If we line things up, repowering coal sites, building multi-day storage fleets, hardwiring data centers to long-duration batteries and new renewables, then we turn the AI boom into a reason to modernize the grid instead of a stress test it might fail.
So where does that leave us right now? Is the US winning this race, or just running the first lap?
We're in the opening sprint. Form Energy has announced around 14 gigawatt hours of projects so far, with pilots at coal sites and one enormous data center battery, but that's still tiny compared with what AI and electrification will demand. The good news is that we've proved multi-day storage can be built, that old fossil sites can be reused, and that tech giants will actually pay for long-duration batteries when the stakes are high enough.
And if we don't want blackouts every time AI ramps up, we probably need a lot more of these Dead coal to 100-hour battery stories, not just one for Google.
That's the race we'll be watching. Whether a new generation of long-duration projects can scale from a few converted coal plants into an actual backbone for the AI-powered grid. If you want to stay ahead of that race, hit subscribe and keep following the Green Blueprint. We'll be tracking every major project that tries to turn yesterday's smokestacks into tomorrow's lifeboats for the grid.